Hello all. So today we're going to talk about solving and graphing with exponential functions. If you haven't already, please print the guided notes out in the blank copy or set them up for yourself in your notebook. Here we've got our homework there. If that's not already in your planner, please make sure that you put that down. So let's get started. So when we talk about solving and graphing with exponential functions, first we want to start off by making sure that we've got this term defined. You've already seen some exponential functions, but there's a wider variety of them. Exponential functions are called that because they all have the form of something times another number to the power of x. So the important thing here is that the variable x is the exponent. It's called exponential functions. So hopefully some of you will recognize this. This is the form of a geometric sequence where p and r are numbers. And it's okay if you don't see a p value. This could be, let's say, 1. So we have a lovely example here in number 1 where p is 3 and r is -2. But it would also be just fine to have an example where you had, let's say, 7 to the x. Doesn't look like there's a p-value, but p is just times 1 here, which we don't write. So let's do a couple problems with these exponential functions. Here it says find f of -2 if f of x is equal to 3 times -2 to the x. So, as you remember from last week, this means that x is equal to -2, and we want to substitute it in the function. So we've got f of x is equal to 3 times -2 to the -2. Now, important thing to remember about exponential functions is you're going to have to follow your order of operations, you're going to have to follow PEMDAS, and of course you're going to have to follow your rules of exponents. So we see a negative exponent here, which means that we're going to turn things into a fraction. So we're going to do our exponent first, turn that into a fraction. This becomes 3 times 1 over -2 to the +2. -2 times -2 is +4. So that's 3 times 1 over 4. Make sure you're watching those negatives in both cases, which is then equal to 3 over 4. Though, of course, if you did this by yourself and you got 0.75, that's just fine. Now, notice we didn't do anything to this side over here, just evaluated it through. So here we're going to ask you to write your own function. We know that 2 points on the graph of an exponential function here are 0, 4, and 1, 2. And we're going to write the function of the graph. Using our formula, f of x is equal to p times r to the x, where we want to find p and r. One thing that might be a helpful way to rewrite this for some of you is remember f of x is the same as the variable y, and we can just do that replacement. And now we have these two x's and y's, which we will use and fill in with the points to find out our answer. Using our first point, 0, 4, we can plug in 4 for the y, and that's equal to p times r to the 0 for the x. Now, here's another nice review of our exponent rules. R to the 0, no matter what r is going to be 1. So then we get 4 is equal to p times 1. And now we've already found our first number. 4 is equal to p. So we've now got this term filled in. We'll use our second point to find r. So plugging it in, we get 2 is equal to p times r to the 1. R to the 1 we can just write as r, and p we know is 4. So 2 is then equal to 4 times r, meaning that r is equal to 1/2, which gives us our second number that we need. Whoop, a little crossed out there, but that's all right because we're going to write our final function, p 4 times, and I'm going to use the parentheses like we saw in number 1, 1/2 for r to the x, and that is our function for number 2. The last thing it asks us to graph our function in problem 2, and the nice thing is that we can use two of the numbers already to start out with. We know our x and our f of x for two numbers because we were given at 0 it's equal to 4, and at 1 it's 2. So those are just given to us already, so we can put those in on our graph. I'm going to find a couple more points to help me along the graph. I'm going to find maybe one on this side and one here. So I'm going to pick the x value 2, which is just this next point here. And I'm going to also find, using the x value of 1, to find this point here. I'm just going to plug it into the function that we wrote in number 2. So with number 2, if I've got 4 times 1/2 squared, that's 4 times 1/4, which is 1. And for -1, I've got 4 times 1/2 to the -1, which is 1/1/2. That becomes 4 times 2, which gives us the y value of 8. So we've got 2 more points to fill in. So these are our points, and we're going to use another fact from our geometric graphs, is that the x-axis is what we call an asymptote, meaning that if I'm looking at the x-axis here, the graph can't cross it. And you'll notice this about all exponential curves, that when I draw in here, we start out really high, and as I go through the points, it's flattening out and I'm not crossing that axis. Put arrows on the end because it would keep going up bigger here, but as it goes here, it's never crossing that line. And so this will tell something about the domain and range of the function. Now, if you looked earlier, domain, these are all the possible x values. So that means all the x numbers that we can plug in. And the range is all the possible y values that we can get out from our function. If we're looking at most functions, the domain can be anything, right? I could plug in 2, I could plug in 0, I could plug in 8, I could plug in -8, that would be very high up here somewhere. So in this case, the domain is all numbers. However, the range, the y values, if I'm looking at my y-axis, I only can use the positive numbers here. So if I'm looking for here, I see that the range is only y has to be greater than 0 because it can't ever cross or touch y equals 0, which is this axis. And that's going to be true, again, for all exponentials. It's either going to be all the positives, or if p is negative, it's going to be all the negatives down here. Again, leave me any questions that you have in the comments, and I'll be available on Zoom, Google Classroom, and by email.